All right, ladies and gentlemen, here we go. Okay, so 4 questions on this Frappy, right? The way that they will score this. They'll score this. If you get an E, you get a point. For every P, you get a half a point. Okay, total of 4 points. That's the way all these are done. Model solution for step 1. The distribution of scores follows a normal distribution with a mean of 22 and a standard deviation of 4. We want to find a proportion that's at least 25. So we'll perform the calculation, show your work. The standardized score is 0.75. That's the Z-score. From table A, the proportion of Z's above 0.75 is 0.2266. Using technology, normal CDF gives you 0.2266 also. The answer to the question, the proportion of students who scored at least 25 points is about 2.3. Scoring A through D.
So why do we use the technology we don't define Z-score?
We're getting ready to see what it says. Essentially correct that the response includes the following 3 components. So you need these 3 components to get an E. You need a use of a normal distribution and clearly identifies the correct parameter values, such as using the Z-score is sufficient. Using correct boundary value, reports the correct normal proportion consistent with components 1 and 2. In other words, no, we'll just go with it. Partially correct if you include only 2 of those 3. Incorrect if it does not satisfy an E or P. Note, the following are examples of clearly identifying the parameters for component 1. Writes mu equals 22 and sigma equals 4. Explicitly labels the mean and the standard deviation in a normal CDF calculator statement. Sketches a normal curve, labels 22 as the mean, and labels 2 additional consecutive values separated by 4 units. Okay, let's look at student's example. This student wrote a normal curve. You got 22, you got 25. I really wish they would have said mu is equal to 22 and standard deviation. They put lower 25, upper. They put mean 22, SD 4. They put 2266. The response indicates use of a normal distribution. Identify the parameters in the normal CDF command. The boundary values were identified in the picture in the normal CDF, and the corresponding proportion was calculated correctly. Part A was scored as an E. I got a normal picture. They told you what mu was. They told you what standard deviation was. They got 0.2266. This student, Z equals 25 minus 22 over 4, 0.75, 0.7734. They indicate the use of a normal distribution because they have Z equals. They identify the parameters in the normal CDF command. This is wrong. This is wrong. I put the wrong key up there. I didn't think they used a normal. Why did I put the wrong key up there? Dadgummit. Where's it at? Here. Come on this page. I need you on this page. Sorry. I got to pull up the right one. Okay. They said the response used a correct Z-score calculation, earning credit for components 1 and 2. I'm surprised at that. However, the response identified the proportion of students who scored at most 25, which is 0.7734, instead of the proportion who scored at least 25, which is 0.2266. Furthermore, the response incorrectly stated that 0.75 equals 0.7734. Because only 2 of the 3 components were correct, part A was scored a P. Okay. All right. Question B. Perfect answer. State the distribution of values of interest. The distribution of scores follows a normal distribution with a mean of 22, standard deviation 4. The 31st percentile is the boundary of X with 31% to the left. Perform calculations, show your work. Look at the body of the table A for a closest to 0.31. A Z-score of negative 0.5 gives the closest to 0.3085. Solving this, you get 0.5 is equal to x minus 22 over 0.4, gives an x value of 20. A whole lot easier using technology. The command inverse norm of 0.31.224 gives a value of 2002. The 31st percentile is about 20 points. Okay, here's how you're going to score B. You need 3 things to get an E. Indicates use of a normal distribution, clearly identifies the correct parameters. Again, draw your picture, label mu, label standard deviation. Most of the time, that's going to get you close to a P right there. Uses the correct area. If you shade it in to the left, you're going to get a P just by doing that without even finding the answer. Then, of course, the 3 is defining the answer consistent with components 1 and 2. Partially correct if you only did 2 of those 3. Incorrect if you did not. Again, we have the same notes. Mu is equal to 22, sigma is equal to 4. Explicitly labels the mean and standard deviation in an inverse norm calculator statement. Sketches a normal curve, labels 22 as the mean, labels the 2 additional consecutive values, correct identification of parameters in part A. Okay? Hopefully I put the right answers this time. This student drew a curve. They do 22. They put 31%. They put a question mark. They did inverse norm, area, mean, standard deviation, 20. This response indicates use of a normal distribution. Identify the parameters in the inverse norm command. The correct area was identified in the picture, and the normal CDF command in the corresponding percentile was calculated correctly. Part B was scored E. Let's emphasize something really quickly. If this student said inverse norm 0.31, comma 22, comma 4, it's no longer an E, it's a P, because they never labeled the mean and the standard deviation. So a calculator talk without labeling those things is no credit. No credit. Okay? If over here they said mu equals 22, standard deviation equals 4, you're okay. But calculator by itself without labeling, no points. Okay? This student here went negative 0.5, x minus 22 over 4. They got 2 is equal to x 22. They got x is equal to 20. Okay? In part B, the response used a correct z-score calculation, earning credit for components 1 and 2, and calculated the correct percentile. Part B was actually scored as an E. It would be tough for me to give them an E without labeling the mean and the standard deviation. However, it's understood that that's the mean and that's the standard deviation. Okay? Part C. Because adding a constant does not affect the measure of spread, the new standard deviation is B times the old standard deviation, which is 10 is equal to B4, so therefore B should be 2.5. Because adding a constant and multiplying by a constant affect the measure of center, then the new center will be 25. The new linear transformation should be 25 plus 2.5 old score. Here's how you're going to get your points for this one. E, the response calculates both values correctly and shows appropriate work. So basically something. Partially correct if the response calculates one of the 2 values correctly and shows work, or calculates them both correctly, but you did not show any work. Incorrect otherwise. Note, if the standard deviation is calculated incorrectly and the mean is calculated correctly based on the incorrect standard deviation, then you can score it partially correct. Not that anybody would do that. So here's what this student said. They said 100 equals 80 plus 10 times the old score. Therefore, the mean value is 80 and the standard deviation is 10. By doing this, you bring the average up, so the mean will be 80 plus or minus 10. In part C, neither value was calculated correctly. This was scored an I. This student said 10 is equal to B for 10, so B is equal to 2.5. 80 is equal to A plus 22, so A is equal to 58. In part C, only B was calculated correctly. This part was scored a P. So you had to basically show some work to get the 2 values, and if you got the 2 values, you got an E.
Okay. So we just have to find B and A.
Yeah, all you had to do is find B and A. Except you had to add an A also. Good, 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 good.
Oh, because it's not, you're not multiplying it on the, wait. Can you go back up to the top?
Yep.
They were like, yeah, we're gonna run a lot.
So we just had to divide the 10 by the 4 here, right? And so this one here, we had to multiply it and subtract it. To get A by itself?
So the mean is just.
Why you have to have it?
That's the only. I don't get why like new mean would just be like kind of how you calculate a B. Why it wouldn't be the same exact thing. Like because when you're calculating a new mean, you have A plus B times B. Why isn't it just like A times B?
Why isn't it just A times B?
Like for the standard deviation, it was just that new value equaled B times the standard deviation. Why is the new mean not the same value? Why is it not just A times B? Why is it B? Why?
So we found the standard deviation here.
Correct.
Okay.
Why is the new mean? Why do you have to have that value? And why is it not just A times?
Like, why do you have that standard deviation?
That's like why do you not calculate it the same exact way?
Because addition and subtraction affects the mean also.
Well, up there you don't have to have the
Addition or subtraction. Because addition or subtraction doesn't affect the standard deviation. Yes.
But like, I feel like I would have just done A times old mean and minus B. Why are we taking away A?
Right.
Why are we subtracting B? Why are we taking away some of the? Why are we not multiplying the old mean by A?
Why? Because A is added to it. A is addition. B is the multiplication. Here, I'll do it. I'll do it later. Okay, D part. D part. If the distribution was normal, scores should go at least 2 standard deviations above the mean. However, in this distribution, the highest possible score is only 0.38 standard deviations above the mean. Therefore, it is inappropriate to use a normal distribution to do calculations. So here's what they said. States a relevant characteristic of a normal distribution. Some relative characteristic. Uses all 3 summary statistics, mean, standard deviation, and max, to show that the distribution of scores does not share the characteristics of a normal distribution. Okay, so you have to use those 3 things to show that, and then concludes that the use of a normal distribution would not be appropriate. So basically answering the question of no. All right. P, if you only hit 2 of those 3. Notes, a response that calculates that 35% should be above 10 in a normal distribution with a mean of 9.2 and 2.1 states that 0% will be above 10 in the actual distribution concludes that a normal distribution will be inappropriate will be counted as an E because you used the mean, the standard deviation, and you stated something that sounds logical. 35% is normal. A response that states that it would be inappropriate to use because the maximum score is 10 is less than 1 standard deviation above the mean should be scored a P because it doesn't state a relevant characteristic of a normal distribution, i.e. in a normal distribution, the max should be 2 or 3 standard deviations above the mean. A response that states that it would be inappropriate to use a normal distribution because 68% of the values should be within 1 standard deviation of the mean, or 95 should be within 2, should be scored a P because, again, the response doesn't show how the actual distribution doesn't share this characteristic. Let's see what these 2 students did. No. So they answered the question right off the bat. On a normal curve, the amount of scores within 1 standard deviation should be 68% of the scores, meaning 16% of the scores should be higher than the first deviation. If the mean score is 9.2 and the standard deviation is 2.1, it would be impossible to have 16% of the scores be higher than the first deviation because the max score is 10. So the response stated a relevant characteristic of a normal distribution, 16%, fall above it. Then use summary statistics to show that the distribution of scores does not share those characteristics of a normal distribution. It is concluded the use of a normal distribution is not appropriate. This was scored an E. Okay? So if you think back, this person scored 3 E's and an I. So they overall got a 3 out of the 4. This student said no, because the mean is too close to the maximum value of points, so therefore you can conclude the distribution is not normal. Okay? So y'all recognize this. The response concludes the use of a normal distribution would not be appropriate. So we got that one. However, the response never cited relevant characteristics of a normal curve. The maximum should be 2 or 3 standard deviations above the mean. Did not use a standard deviation in the data to quantify the assertion that the mean is too close. Part D was scored in I. So this student had 1 E and 2 P's, therefore it was an overall a 2. You get a full point for an E and a half a point for a P. Yep. 2. That one? Yep. Questions on this? Very, very, very good questions. Okay, very good questions. Let me ask you something that may or may be misread. Listen to me, don't answer, just answer in your head. If a distribution is not normal, if it's not normal, in other words, we don't know what the shape is, can you still find a z-score? What is the definition of a z-score? Who knows what the definition of z-score is? Hit me. The value is from the mean. Number of standard deviations, the value is from a mean. Does it have to be a normal distribution? You can find a z-score for any value, no matter what the shape is. Can you turn that z-score into a proportion? No. Unless you know it's normal or it's uniform. I guess you could if it's uniform, because we know how to do a uniform. Fair enough with that? So uniform, you can find it because it's going to be length times width. It's the area underneath the curve from that z-score to whichever one they're asking about. Normal distribution, you can use normal CDF, or you can use a table, or you can use Desmos. But if it's not one of those, guys, we don't know how to find the area underneath the curve. Okay? Please remember that Wednesday. Please. That's like several questions. If you don't know that you can still find the z-score, you can. You can find the z-score for anything. It tells you it's that many standard deviations from the mean, either above or below, right? I'm supposed to say above or below. I can't turn that z-score into a proportion. All right, your task today, rest of this class period, please use it correctly. You have the review from the book, okay? Those 10 questions, okay? I did it differently this time. If you missed it, you have to explain why you missed it and explain why what's right. And if you don't do that, that's fine. You just probably won't end up with your full points, okay? If you explain it and you do a good job of it, then we'll give you your points. And then I posted on Classroom, you have 2 reviews here, okay? 20 multiple choice questions, 10 and 10, okay? Just like last time. You look at the question, you can answer it or not answer it. When you hit next, it will give you the answer, okay? Those are great questions because they're not just going to be dead set on some decimal answer. They're going to show you how you calculate it. And it's going to ask you something. It may do something like 2 times the z-score. Or it's going to just do some different things that you guys have not seen before that you should understand, but it's just a different way of looking at it. Okay, different way of looking at it. And I thought I had another Frappy, but I don't remember where I had that. Good enough? Your test Wednesday will be on your computer. Okay? I have it on paper. You can do it there also. I don't care. But if you're going to use Desmos, you got to do that. Okay? You got to do that for Desmos. Yep. Yeah, now the FRQ will be on paper. So the question will be on it. You just write it on paper. Okay? So your answer sheet's going to look just the same. It just won't have a bubble sheet. Unless you want to do it on paper. I'll give you a bubble. I'll do some. Okay? All right.